Okay, so example, Britt, who isn't even here, let's do card questions because you guys love them, right? Draws a card from a proper deck. What does that mean? Yeah, no jokers. No jokers playing it, no jokers in the deck. What is the, now this is something like, well, it's probability, but it's like different, okay? Odds in favor. Now, I don't know if we're supposed to spell favor like that. That's a Canadian way of spelling it, but in math, is that how it's spelled too? I'm not sure, whatever. Okay, so it's in English. Odds in favor.
Teachers, please excuse this interruption. Would all grade 9s please make their way to room 108? Thank you.
That she draws a face card. They don't mean mentally, they mean your actual grade that you're registered in.
Wow. Alright, well that was different than Shelley.
Okay. Ashley was asking for Shelley, right? Okay. Shelley was just kidding.
Said it.
Okay, so I think you could figure out what the odds of you drawing, not the odds. I think you could figure out the probability of drawing a face card, and we'll go right in a sec. This would be like grade 8. You were kind of know how to do this, right? If I put 6 marbles in my pocket, one of them's blue, what's the odds of me putting my hand in my pocket and pulling it out, the blue? Can you let me finish that question? Yeah, 1 in 6, right? Unless they're all blue, and then what's my probability of pulling out a blue marble? 6 in 6, otherwise known as 1, otherwise known as 100%, otherwise known as, well, what other choice would you have, right? Pull out no marble? Tricked you. Okay, so what is odds in favor? Now let's write it the American way this time. Okay, that is a ratio of favorable outcomes to unfavorable outcomes. Okay, which is different than probability, which is favorable outcomes to total number of outcomes, favorable and unfavorable. Okay, if I got 6 marbles in my pocket, well, that's my choices. Either I pull out one of those 6 marbles. Which ones are blue? Which ones are favorable? The blue ones. If the other ones aren't blue, those are the unfavorable ones. But there's 6 marbles. They all got to add up to 6. Okay? How many cards in a deck? Proper deck? 52, right? But it's not asking you how many face cards are there? 3 per suit. There's 4 suits. 12. Yeah, it's not saying what's 12 divided by 52. Okay? It's saying what's the ratio of favorable outcomes, 12, to unfavorable outcomes, which means not a face card. So if there's 12 face cards, how many cards are not a face card? Yes. Okay, that's what it's saying. That's the odds in favor. Okay, so favorable outcomes. In other words, face card. That's 12. Unfavorable. Right? Well, what's 52 minus 12? 40. That means not a face card. Now, what did we have? We had letters. Last chapter. So I could just say that's F, and then what would I denote as not F? F with that little line there, F prime. Okay? So this means F. That means last time we called it the complement of F, right? Now we're just going to say not F. not a face card, which means, you know, ace, a 2, a 9, whatever. Okay, so what is the odds in favor? It's a ratio. What's another word for ratio? Fraction. 12 to 40. Or 12 to 40. You remember seeing that? Grade 8? Because I don't think you've seen it since. I don't know. Yeah. When you build a model and it's in scale, they use these proportion dots, right? 1 to 32. That means the actual car is 32 times as big as your model. Oh, we did this in grade 11, sorry, in foundations. Yeah, not in pre-calculus. Some of you did. Okay? So, that was odds in favor. The other side of the coin here is, what are the odds against? So really similar, just different. Well, I did 12 to 40, so this is going to be, 40 to 12. Now, can I simplify that? So I didn't do it here, but yeah, if it's, your answers are always going to be simplified, right? Okay, it's nice to have the numbers because you know there's 12 face cards, but as a simplified answer, well, you know, 4 goes in there 3 times, 4 goes in there 10. So this would also be written as 10 to 3, and that's how the answer in the back will be. Okay, they simplify them. Yes. Yeah. Okay, so as an answer in a book, I kind of prefer to see it like that because that has more meaning. 12 face cards, 40 non-face cards. It's not all of a sudden you got 10 cards and 3 cards in your deck, right? But they still simplify the answers, okay? Just to let you know. Okay, so that's the unfamiliar one. Let's do the familiar one. Probability. By the way, who remembers, what's the probability of winning Lotto 649? How many different ways could you choose 6 numbers from 49? Remember that?
Wasn't it like a big, big number?
It was a big, big number, like 13.8 million different ways. So the odds of you winning is 1 in 13.8 million, right?
It's good odds.
49, choose 6. Yeah, 1 in 13.8 million. What's the likelihood of you being a Prime Minister of Canada? How many people are in Canada? 31 million? Yeah, well, you know, you think it's probably better than that, isn't it? Every 2 people, if it's 1 in 15 million, you know, it's like 1 in every 2nd person. That's pretty close to winning the 649. I don't know. What's the probability of drawing a face card? So, here's it as a formula. How many face cards are there? There's 12. What is the total number of cards in a deck? Well, it's 52, but how else can I write that? That's face cards and not face cards. Is there anything else to choose from? No, that's it. That's the total, right? That's the total sample space, if you will. Okay? So again, I could also say that is the number of whatever you might be talking about to the total. Okay? So 12 over 52. Again, your answer is going to be simplified. Okay? 2 goes into there 6 times, 2 goes into there 26 times. I can still cut that in half. 3 to 13, 3/13. That's your odds. Why do I use that word? That's your probability of drawing a face card. If you pick one card out of the deck, okay, you got a 3 in 13 chance of it being a face card. Okay? So one thing I want to say, I'm not going to write it, that's in theory. Okay? In theory, that's what will happen. In practice, if this was an experiment, and I gave you a deck of cards, and you pulled out a face card, you might come to the conclusion, hey, I pulled a face card, it must happen 100% of the time. Right? And in experiment, you'd be true. If you didn't pull a face card, you'd say, I'll never get a face card. Did you ever do this in elementary? Did you flip coins, heads and tails?
Never.
Yeah? Some of you say, yeah, that'd be the first thing I did if I was an elementary teacher, right? Okay, and yeah, any given one flip, is it a head or a tail? Well, if you just flipped it once, you would have no idea. But the more times you do it, and if this kid does it 20 times, and this kid does it 20 times, and that kid does it 20 times, the more times you do it, the more it's going to approach, in theory, what should happen. 50% of the time heads, 50% tails. Right? So this is in theory. Okay? Now, what's the formula for odds in favor? Okay, that's what we did. Probability of a face card over the probability of not a face card. So as a formula, that's what it is. And in general, for anything then, it would just be P of A over P not A, regardless of what A was. Irregardless. So odds against, well, take the inverse. Okay? So in general, that's what you do. So we did this, that was 12 to 40. Okay, and this one was 40 to 12. All right. So the probability So what's the probability of drawing a black ace? How many choices do we have to draw a black ace in a deck of cards? There's 2 spades. Not 2. There's an ace of spades. There's an ace of clubs. Yeah. 2 out of, what's the total choices? 52 cards, right? Okay, simplified, that's 1 out of 26. And yeah, maybe we'll make it a decimal sometimes too. Okay? So it might be written like that, might be written as a decimal. They just divide 2 divided by 52. So determine the odds in favor. Well, of the same thing, right? Same question. So look at your previous example. What was odds in favor? Okay. For getting a face card, there was 12 ways I could get a face card in a deck of cards. Okay? Divided by the number of ways not to get a face card. So this would be Anyone want to take a stab at it? 2. How many ways to not get a black ace? If there's 2 ways to get it, then there's, yeah. Okay? Or odds in favor, 1 to 25. Okay, so odds against. Once you got one, the other one should be easy, right? You already got the numbers. Well, if there's a 1 to 25 chance of getting the black ace, then there's 25 to 1 chance of not getting it. So again, it can write, sorry?
Why is it 50?
Well, yeah, this isn't the total. This isn't probability. Odds against, again, do you want to see it in words or do you want to see it as a formula? Okay. Where do we got it? The not a face card, there's 40 cards not a face card. There's 50 cards that are not a black ace. So that's just, like I say, we don't, when we do probability, we can kind of skip this part, but that's what this book has. It's odds against, odds in favor. Okay, last one. What is the most popular color for cars on the road? Think so?
White. The most common color.
When you said it.
Red. I don't think it's red.
Rainbows.
Rainbows.
Yeah, it's white from what I read. But again, where did that information come from? Maybe it's different in Europe than the States, than Canada, but that's what I did read. If you get in if you get in an accident, the odds against colliding with a silver car, which is the second most popular color. It used to be the most popular. Yeah.
Silver cars.
There's lots of silver trucks,
No.
but that includes that kind of off grayish color too, right? Because it's not black, white, red, blue, then all those kind of colors off in between black and white, that's gray, that's silver, right? Gray, same thing.
No.
So, the odds against colliding with a silver car is 41 to 9. My hand is not working today. Determine the probability that if not getting in an accident, but if you get in an accident, the car will be silver. I guess you could say that's the same probability of your car being silver too. Because if that's the statistic, then it applies to everybody. All right, so this is an understanding of the difference between probability and odds against, odds in favor, okay? So look at our example here. If I'm giving you the odds against, what does that mean? That's 25 to 1. What's the total here? Because this is the total sample space, right? This is odds against, and this is odds for. Like there's 25, what was this? 25 choices to not be a black ace, 1 choice to be the black ace, and that's the only choices you have. Okay, so this is the total, right? So what's the total here? Odds against. There's 41 choices there to not hit the silver car, and there's 9 choices to hit the silver car. So what's the total? Total's 50, right? So as a formula, here's what we're saying. The probability of silver is silver over silver and not silver. That's your 2 choices. Either it's a silver car or it's not a silver car. That's the total. Okay, so that is 9. That's silver because this is odds against, not odds in favor. So it's the second one we want. The total is 50. So the probability is 9 and 50. Which is maybe not making as much sense as what we can make that as a decimal. What is 9 divided by 50? I shouldn't have to put that in my calculator, should I?
Yeah, you should.
If you got 9 out of 50 on your test, Ashley, you'd be overjoyed. But secondly, what would be your percent?
You're such a jerk.
Thank you.
I'm not even answering it now.
Double it.
No.
50, make it 100. 9 is 18%, right?
Wow. Whatever, I beat them on the test, so.
Well, okay, that's 0.18. I'm just bugging you. Yeah, which is 18%. No, you did good in the last one.
I think that was really good.
Let's reword that. What percentage of the cars on the road are silver?
18%.
18%.
Good job, man.
Yeah,
That's what I'm gonna get on the next test.
that's the spirit.
I can't wait. I'm gonna aim for the sky.
And 14.
Yeah?
And you all have it done in 15 minutes to go. All right.